Black holes, mysterious, powerful, and beyond comprehension. These cosmic giants bend the very fabric of space and time, but today, we're going to focus on something even more mind-boggling. The largest known black hole. How large is it? What happens to an astronaut if they fall into it? And could we ever harness its unimaginable energy? We'll dive deep into these questions, exploring the science and the mysteries that surround these gravitational monsters. Get ready for a journey that takes us to the very limits of the universe. Before we dive into the specifics of the largest known black hole, let's first understand what a black hole actually is. In simple terms, a black hole is a region of space where gravity is so strong that not even light can escape. This intense gravitational pull is caused by a massive concentration of matter packed into a small space. When a massive star runs out of fuel, it can no longer support its own weight. The core collapses under its own gravity. And if the star is massive enough, this process leads to the formation of a black hole. These black holes come in different sizes. From stellar mass black holes, formed by the collapse of individual stars, to supermassive black holes that exist at the centers of galaxies. The one we're going to explore today is in a class of its own. The largest known black hole is called TON 618, a supermassive black hole located about 10.37 billion light-years away in the constellation Canes Venatici. It's not just large, it's unfathomably massive. TON 618 has a mass roughly 66 billion times that of our Sun. But even that is only one way to describe its enormity. Let's break this down. TON 618 is so massive that if it were placed at the center of our solar system, it would stretch out past the orbit of Pluto. The gravitational pull it exerts is so strong that it distorts the very fabric of space-time around it. This distortion of space is called gravitational lensing, and it can bend the path of light itself, allowing us to observe objects behind the black hole, but in a warped, distorted manner. TON 618's accretion disk, the hot, swirling mass of gas and debris falling into the black hole, emits a tremendous amount of energy. In fact, this black hole is one of the brightest sources of radiation in the known universe. The light and other emissions from its accretion disk are so intense that they outshine the combined light of all the stars in its host galaxy. And this is just the observable impact of TON 618. When it comes to understanding just how massive TON 618 is, we need to think in terms of size and mass, but also in terms of its reach across space, the Schwarzschild radius, or the size of the event horizon. For TON 618 is over 200 billion kilometers. For reference, that's about 1,300 times the distance between the Earth and the Sun. Imagine the sheer scale of this black hole, space. The event horizon is a point of no return. If something crosses this boundary, it's gone forever. It's here that the black hole's gravity becomes so overwhelming that nothing can escape its grasp. In the case of TON 618, this boundary encompasses a region of space so large that our entire solar system could fit inside it, and then some. To give you another perspective, if TON 618 were at the center of our Milky Way, its size would make the galaxy look tiny. Our galaxy spans about 100,000 light-years across, and TON 618's event horizon would stretch out across millions of light-years in comparison. Let's imagine a scenario. An astronaut, bravely floating through space, finds themselves on a collision course with TON 618. What would happen if they fell into this black hole? At first, everything would seem normal. The astronaut wouldn't feel anything unusual, but as they get closer to the black hole, the effects of its gravity become more noticeable. A key concept here is spaghettification, the process where an object is stretched and torn apart as it approaches the event horizon. The gravitational forces are so extreme near a black hole that they differ depending on where you are. If your feet first, for example, your feet would experience a much stronger pull than your head, causing your body to stretch out into an elongated shape. As the astronaut falls further in, the stretching would become more extreme, and eventually they would be torn apart long before reaching the event horizon itself. Once past the event horizon, the astronaut would experience something strange. Time, from their perspective, would appear to move normally, but for observers outside the black hole, they would appear to freeze in place and frozen at the event horizon. The closer the astronaut gets to the singularity, the point at the center of the black hole, the more intense the forces become. Beyond the event horizon, the laws of physics as we know them cease to operate in a predictable way. The astronaut would be crushed by infinite density at the singularity. Now, let's move on to one of the most exciting and perhaps practical questions. Can we ever harness the energy of a black hole like TONE 618? Black holes are not just destructive, they're also energy powerhouses. A supermassive black hole like TONE 618 produces enormous amounts of radiation and gravitational energy. But the real question is whether we could ever tap into this power. The most promising theory is something called the Penrose process. The Penrose process suggests that it's possible to extract energy from a rotating black hole by splitting particles near the event horizon. One part of the particle falls into the black hole, while the other escapes, carrying away energy. This process could, in theory, provide a way to extract energy from the black hole. Though we're still a long way from developing the technology to make it a reality, there's also the possibility of harnessing energy from the accretion disk, the hot, swirling gas and debris that orbits the black hole before it falls in. This material emits radiation across the entire electromagnetic spectrum, from X-rays to gamma rays. With enough technological advancement, it might be possible to capture this energy and use it to power distant space missions, or even entire civilizations. But there are immense challenges to overcome. The radiation emitted by black holes is incredibly high energy, and harvesting this power without being destroyed by it is a significant hurdle. Additionally, getting close enough to a black hole to use its energy would require technology far beyond anything we have today. Despite the challenges, black holes offer a tantalizing possibility: the ability to harness the energy of the universe's most powerful forces. If humanity can figure out how to extract even a small fraction of that energy, it could fuel space exploration for centuries to come. Black holes are some of the most mysterious objects in the universe, and we're just beginning to scratch the surface of understanding them. As technology advances, we're able to observe them in more detail, and with upcoming space telescopes and missions, we'll continue to learn more about these cosmic giants. Future missions like the James Webb Space Telescope and more powerful gravitational wave detectors will help us peer deeper into the universe, potentially uncovering more supermassive black holes and even observing the process of spaghettification in real time. These discoveries could reshape our understanding of space, time, and the fundamental laws of physics. While the possibility of harnessing black hole energy remains distant, the knowledge we gain from studying them could revolutionize science and technology in ways we can't yet imagine. Black holes continue to captivate our imagination, challenging our understanding of the universe and the fundamental forces that govern it. With objects like TONE 618 pushing the boundaries of what we thought was possible, the future of black hole research holds limitless potential. Thanks for joining me on this incredible journey into the depths of space. If you enjoyed this exploration into the largest known black hole, make sure to subscribe and hit the notification bell so you don't miss our next deep dive into the wonders of the cosmos.